Hello, everyone, and welcome to part 5 in our special Cercospora leaf spot database series. If you recall from my agenda, part 5 deals with the science of the organism. It's specifically entitled Cercospora beticola, or CLS epidemiology. Epidemiology meaning the life cycle of the disease. I'm going to subtitle this Understanding the Beast, because if we can understand the epidemiology or the life cycle, we can most effectively identify the times of the organism's life cycle where it is most vulnerable to the shock and awe from the improvements we're making to Cercospora leaf spot strategies. If you have been here through all 4 of the previous portions of the series, I commend you for your dedication, and please enjoy this part 5. As I mentioned before, I promised you there's a very, very, very good video produced by the American Phytopathological Society that takes you right down onto the leaf to understand the organism, and I think that you could all enjoy that portion. But before we get started, as I mentioned, to understand the biology and the life cycle of a disease organism does involve a little bit of science. And so to introduce a little bit of levity, I'm going to bring in a comic strip by Wiley Miller. And in his comic strip, he talks about the world of science versus everything else. And he goes on to say that there are answers that we can derive, but some of them are simple, but they're not entirely correct or flat out wrong. And then there are those that are more complex, or they involve a little complexity, but they have the greater propensity to being right. The problem is that in today's society, there are so many people that would prefer to take the simple answer, even though it may not be entirely correct, and then follow each other like lemmings off the cliff. Whereas the road less traveled, the one that's uphill all the way, the one that involves more complexity, is often the one that can give us the most correct answers, the one that will lead us to the promised land, which of course is a disease-free field in October, where we stand the greatest opportunity to gain a profitable sugar beet crop and process it, and then be able to process it. So as I said, this whole understanding of the life cycle involves a little bit of science. So with that, let's jump into that presentation. I promised you, please enjoy the presentation. I think it does a great job of explaining what we're after from a moonshot view, getting right down onto the leaf and understanding the organism.
The typical symptoms of Cercospora beticola are circular spots with sharply defined reddish-brown borders. At the center of these spots, but visible only when magnified, are fungal structures. These are conidia of Cercospora beticola. Each elongated hyaline spore is individually attached to a dark conidiophore. The conidia are easily detached from the conidiophores by the wind. Raindrops can also splash the conidia off and transfer them to young leaves. If the relative humidity is sufficiently high and the weather is warm, the conidia rapidly germinate, often producing several germ tubes simultaneously. These primary hyphae cover the adjacent leaf surface, forming a mycelium. Next, secondary hyphae begin to branch off. They penetrate through stomata and thus infect the leaf. In the cavity beneath the stoma, the hyphae quickly ramify and spread. From here, they grow into the leaf tissue between the parenchymal cells. The mycelium releases substances which, when exposed to light, are toxic to the plant's cells. The damaged cells turn brown. The tissue dies. For the fungus, this dead leaf tissue is a source of nutrition. Now the hyphae cluster together, forming a stroma. In humid weather conditions, new conidia grow out of this stroma, again in clusters, on their conidia.
So as you can see, there is This particular organism is a reproductive machine. It can produce thousands and millions of these conidia. They can be transferred to other leaves. They grow out into hyphae and mycelial mats, all of them capable of producing multiple germ tubes and capable of penetrating our leaf stomata. So reproductive machines. And in order to understand how we can control this, we need to understand the disease. So I want to take you back to a slide that I presented in an earlier segment of our series, talking about the financial penalty for each incremental increase in Cercospora leaf spot rating. As I mentioned, even going to a 4, we had up to $63 per acre, plus the 34 is $100 per acre total. But then going from a 4 to a 5 was a $224 penalty in and of itself. So the grand total of going from a Cercospora leaf spot rating of 2 to a 5 was well in excess of $300 per acre penalty. So we certainly understand the importance of delaying the onset of the disease, because we do not want to let it get to these economic thresholds that exist farther up the category scale. And that gets to, as I mentioned, the importance of delaying disease onset toward avoiding economic threshold. And if you recall that the Cercospora leaf spot damage categories that were produced, that was created back in the 1980s and 90s, indicated that a category 6 was what they considered to be economic threshold. However, some of the data that we've been collecting in southern Minnesota beet sugar, where we are in one of the more hotspot areas for Cercospora leaf spot infection, I think it's fair to say that we probably need to consider a new threshold that exists somewhere around that category 4 to category 5, where we experience that slippery slope to that financial penalty for allowing the Cercospora leaf spot disease to get that far along. Now, in order for us to be defoliating our sugar beets in October at this category 3 is going to absolutely require that we delay disease onset and stay front end heavy on controlling this disease, because we know that early infections can turn into really big problems later in the summer when it acts as a heavy inoculum. Now, I've had many shareholders tell me many times that they get really apprehensive at the end of August and September, because that's where they've seen their fields blow up. And you might be wondering as to yourself, exactly why do we see this tend to happen? What environmental factors? Well, it just so happens that it corresponds with the leaves being able to, the Cercospora leaf spot organism being able to start to infect the leaves, but also something very important happens at this time of year. And that is, what else do we tend to observe more frequently in the late summer to early part of September? Well, our nighttime temperatures get quite cool. And so it's actually nice to sleep at night, but we are starting to reach our dew points. We start to cool into the dew point range, and we have free water that exists on the leaves in the morning. And we'll learn a little bit as we get into some of the later slides here on just how important this free water is. But before we go there, to understand infection categories, you need to understand how the methodology works when we go out to make the ratings. Now, all of you have been out and we're getting very, very familiar with these leaf spot damage categories. And I'm very proud of the work that everyone's done, because now we can speak the same language. But when the research staff or myself go out and try to do 173 fields, we do not have a lot of time to go in and start lifting the leaves up to look at what's underneath, right? So we're standing up, maybe bending over a little bit, but we're generally getting a perception of the visual appearance of the leaves from the upper mid to top part of the leaf canopy. So what I'm saying is visual field ratings are heavily influenced by the visual infections in the mid to upper canopy. So therefore, by definition, a category 3 Cercospora leaf spot category already has a fair amount of spots that exist in the upper canopy just by the way we rate the leaves. And so I showed these leaves before, and you might have noted that late season infections, I gathered a lot of these leaves, and they tend to have infections in the late season that tend to occur in clusters, this half of the leaf, or down in what I would call the whorl or the growing point of leaf here, clusters of infections rather randomly distributed. So what are you talking about when you talk about these late season clusters, and why should you care? Well, let's take a look at that a little bit more. First of all, we need to understand, again, that if we understand this life cycle, we can keep our friends close and our enemies closer. And this is how CLS spreads and germinates. This is from work conducted by Viviana Rivera Varas and Gary Secor out of NDSU. And obviously, the things we already know, and that is that with increasing temperature, we do tend to see increases in the germination percentage of our Cercospora leaf spot spores. But you saw the video talk about the importance of relative humidity, but these researchers at NDSU said that yes, relative humidity is important, but the vast importance relies on this free water. Okay, if there's free water present, evidently that is like a cesspool for these particular organisms to germinate and be able to spread. So the free water seems to be a very important part of the Cercospora leaf spot life cycle when you look at the data produced by these researchers. And then you walk out into fields or into the ditches and your feet are all wet before you even get into the sugar beet field. And then you walk out of the sugar beet field and there's literally water sitting on the leaves. Perfect environment for this free water. So when we go back to talk about late season infections, it's so easy to see that if we have a category 3 in the upper canopy, that there's lots of opportunity for it to germinate because of the free water that occurs in late August to September. So if I take a look at those leaves again once more time now and put this into perspective, so we have these infections and let's understand how this occurs. So we have a category 3 or a category 4. Not that we all want to. In fact, we're doing a very good job of preventing that to happen. But when we do see a category 3 or category 4 exist in the upper canopy, as symbolized by these leaves right here, and they all are abundant in these conidia, these hair-like structures that you saw in the video. And now we have all of this collection of free water in the folds of the leaves because we're reaching our dew points in the middle of the night. It's easy to see that there's no need for the organism to rely upon wind or rain splash anymore. All it really needs is gravity feed. It drops from the lower leaves into these cesspools for infection points. And now we have germination of gobs and gobs of Cercospora leaf spot spores. So my point being here is that once Cercospora leaf spot climbs to the top of canopy, we have a 3 or 4 rating. It's no longer reliant upon periods of humidity, wind, or splash. All it needs is gravity and morning dews to create a slippery slope of unimpeded reinfection cycles. In fact, basically what I'm saying is it is self-reliant now. It relies no more on Mother Nature. It can do its own reproducing and spreading simply because it's got all of the factors that it needs. And why is this so important? Well, what I was able to do is go out to the research plots and evaluate some of their disease, their not untreated checks. I also was able to go out and visually evaluate a lot of sugar beet fields. And what I was able to do is start to put a little bit of a standard curve on the rate of increase of the disease from certain category ratings. So for instance, if we look, especially when we talk about the gravity feed or later in the season. So if we look at something that's already at a category 3, if we have conducive environments, we could be reaching economic threshold in literally less than 2 weeks. Even a category 2 later in the season, if left untreated, can be reaching a proven economic damage threshold at that 4, 5, at something just over 2 weeks. However, if you have been able to keep your field relatively clean of Cercospora leaf spot and have a 0.5 to a 1 rating at the end of your treatment range after you've sprayed and you've let it go the first full 12 days, you still have another potentially 4 to 5 weeks before you're going to reach economic threshold just because of the disease cycle. It needs to cycle several times in order for itself to be able to get to the point where it can logarithmically start to reproduce upon itself. So early season control, delaying the onset of the disease, buys us lots of time at the end of the season. So let's talk a little bit about this life cycle, finding the most vulnerable stages of the disease and how that relates to obtaining as much shock and awe as we can from our fungicide program. As I mentioned in a previous presentation, shock and awe, you've heard it before from a military sense, is a tactic or a strategy based upon the use of overwhelming power and spectacular displays of force to paralyze the enemy and eliminate its will to continue fighting. And I like that last portion because when we put it into a noun, as in the agronomy sense, It would be your farmer tactics that recognize the value of precision application techniques to increase leaf coverage and then overwhelm and paralyze the enemy to eliminate its will to continue fighting. Basically, eliminate its ability to create more spores. And that really gets down to the whole shock and awe theory, is going out there and obliterating the enemy. And in understanding this whole shock and awe, I still want to get you down onto the leaf surface a little bit more, even though more so than we did in the video, if you will. I'll try to move really quickly. So let's get this whole fantastic voyage and these spores into perspective. So we look at the penny, we look at the eye of the needle, we look at the head of the straight pin, and then we start to measure that. We're about 1.5 millimeters across on the size of that straight pin. And if we take a look at the grains of salt, then that means that if we place that grain of salt on that head of that pin, that's approximately the way it might look. So we get a little bit of perspective now. Now, if we take a look at a leaf about the size of a grain of salt on a leaf, this is 350 microns across, about the size of that grain of salt. There are 7, 8, or 9 even, I only count 7 here, but I think there might even be one over here, 8 or 9 potentially stomates on this relatively small portion of this leaf from a scanning electron microscope. Now, if we understand how many spores are 350 microns, now we can start to understand that each one of those, if how many stomates are on a 350 micron segment of leaf, we can start to understand that when these conidia grow out of the stomates, each one of them can be able to produce these little portions that are only about 0.2 millimeters in size. And we throw that little portion, that reinfection portion that you remember from the video, onto that grain of salt. This is the size we're talking about. No wonder we don't really know what our disease is doing, because it's very, very hard for our naked eye to see these types of small organisms. But in reality, if we take a look at the conidium growing out of the conidiophore on the leaf that we saw from the video, and then we put that in perspective to a grain of salt size of your leaf with 7 to 8 stomates, each one of them capable of reproducing more conidia, we can see the monstrous ability for this disease to procreate itself. And then if we take a look at a particular spot, knowing that each one of these spots has numerous stomata on them, if I was to put those pieces of salt on this spot, it would look something like this. So basically, each Cercospora leaf spot on a sugar beet leaf possesses hundreds of leaf stomata, each capable of acting as a portal for a vast number of CLS spores, and then also the re-exit portion for the disease conidia. So each one of the dots on this is a stomata capable of producing multiple reinfection spores. So you can see the immense reproductive potential of the disease from just one single spot on your leaf, because each one has the capability of producing more stomates and then a conidiophore and all of the hair-like structures that can go on to move to other leaves in your field, unless we can do a really good job of coverage. So those water droplets coming on there would be hopefully something that would exemplify what we're trying to do when we spray. So if we can get really good coverage at the time before these conidia have a chance to infect your leaves, we can get the most shock and awe from our Cercospora leaf spot program. Remember this: almost all disease organisms respond to the disease triangle, okay? And that means that you have to have a favorable environment, a viable host, and a susceptible host and a viable pathogen, right? And there's not a lot of things we can do to change our environment. A little bit, we can spray at certain times of the day. Not much we can do to our host, although there is some new highly Cercospora leaf spot tolerant varieties coming out. But the thing we can do in 2021 is we can take the pathogen out of its comfort zone. And it really doesn't take a lot of major shifts to do that. If we can do just a little bit to take that pathogen out of its comfort zone, we can go a long ways towards reducing the overall potential of the disease to get a foothold in our field. Remember that attention to detail with your spray technique and your environment and all of your spray equipment can take the disease out of its comfort zone and make it lose its will to continue fighting by maximizing shock and awe. To exemplify this, I do want to remind you of some fields of some farmers that allowed me to convince them to quit spraying a portion of their field so I could compare it to the sprayed portion of the field and start to understand and how to develop that model that I created on how fast disease can can become a problem later in the season. And if I could explain each of these next two fields, basically the farmer had sprayed and had coverage through the blue box here, right? And that was where he actually made the skip. He left a portion of his field unskipped, and you can start to see the untreated checks start to separate from where he sprayed. But the portion that I want to bring to your attention to is that he sprayed again here on the early part of September, and look at the shock and awe that he achieved. He was starting to see increases in Sarcos leaf spots by my visual evaluation, and when he sprayed, it leveled right off. In fact, the strip was narrow enough that I think he started to get actually a little bit of shock and awe, even that had moved off onto his untreated check. If we look at the field number 2, same basic premise. The farmer had coverage through about the 24th of August. That's when he made his skip. We did not see separation till a little bit later, about the time that he made his next application. But again, he made one more application in the middle of September, and you can see the leveling off from the shock and awe. So multiple shocks and awe from your fungicide program throughout the season, especially early on, front end heavy, can control this disease and prevent its ability to be able to create this reproductive machinery. So the basic premises behind your shock and awe management: shock and awe recognizes that a good spray day is a good day to spray. Meaning a lot of folks have always tried to predict the weather and decided that they weren't going to spray because it was going to rain anyway, and they may get it all washed off. And I'm saying, if you have a good spray day, even if there's rain in the forecast, get your shock and awe, because we need to control the disease. We certainly can't allow it to get a foothold with free moisture because of the rain and then not be able to get back in the field because the field is wet. It also requires you to modify your spray intervals within reason to achieve conditions that increase efficacy rather than overly strict adherence to the intervals. Okay, that's the shock and awe theory. It still requires you to monitor disease index values, okay, because that is going to be able to help you predict a relative time frame to look for that ideal spray day without lengthening your intervals too much. Consideration to attention to detail relating to the additive effects of relatively small additive BMPs. We talked about that before. We need to make sure that we're doing everything correctly to maximize our shock and awe. And then when a field reaches a value of 3, a certain amount of our impact is lost. We need to recognize that it's front end heavy based. We need to get shock and awe early in the season, prevent ourselves from getting past at level 3, because then the disease starts to take on a life of its own. It doesn't rely upon Mother Nature. It can self-perpetuate itself. So bottom line, here's the end of series number 5 and the end of the entire series. If I was to summarize part 5, it would be this: CLS, Sarcos leaf spot, possesses a defined life cycle that is generally unknown to us because it's so small that we can't see it. However, modern microscopy has enabled scientists to observe and animate the life cycle for us to assist with understanding the stages where the disease is most vulnerable to our ability to go out there and get good shock and awe with a fungicide program. Fungicide efficacy from a repeated shock and awe coverage is imperative to delay the disease from getting a foothold and prevent it from being able to self-perpetuate itself. Because once leaves become infected, they no longer require much assistance from Mother Nature. They can do it all on their own based upon gravity feed and the free moisture that we get from dews later in the season. Remember this: additive effects of small improvements to our overall control strategy are enough to take the disease out of its comfort zone so we can grab the steering wheel and navigate our ship. We have control of our destiny, and we can control the disease in 2021. My final comments would be this: a poll of the ag staff suggests that 25% of our cooperative operations have an employee spray their pesticides, or they have a custom application done by an agronomy center or by the air. And I want to ask you, are these folks getting the message about the importance of spray technique and equipment BMPs in the interest of obtaining shock and awe fungicide coverage to achieve the best control possible with our current products and application strategies? And with that said, please talk to your commercial applicators and or your employees about some of these best management practices in the interest of everyone controlling the disease in 2021. And with that, I'd like to say thank you and good luck this coming season. I'm going to stop my share and look forward to talking with you again.